Hello, welcome to my channel Speak with Math. Look at the problem on the board. Find the volume of the solid formed by the revolution about the major axis of an ellipse with axis 2a and 2b where a greater than b. Since a greater than b, the major axis is x-axis. Then to find the volume of solid of revolution, we can use the formula, that is revolution about x-axis. V is equal to pi into integral a to b y square dx. How we can approach to this formula? Consider a region bounded by the curve y is equal to f of x on interval a to b on x-axis, that is this region between the curve and x-axis. If the region is revolving about x-axis, we get a solid of revolution. This is point B and this is A. Now consider a disc inside the solid, a small portion that is a disc shape form. Here we are using disc method to find the volume. Now what is the volume of this disc? dV. We know that the area of this disc is what? Area pi. This is the radius. Here it is y. That is area is pi into square of radius, that is pi r square. Here it is pi into y square. Then what is the volume? Volume is area into this thickness. Area of this disc into thickness of this disc, that is dx. That is pi into y square into dx. Then what is the total volume of this solid? Total volume of this solid means what? Sum of volume of all these type of disc inside this solid. That is the total volume of solid. That is from A to B. So to get the total volume, we have to integrate it from A to B y square dx. Pi into integral A to B y square dx. And this method is called disc method. Now consider the given problem. Here the given find the volume of the solid formed by the revolution about the major axis of an ellipse. So the equation of ellipse is what? X square divided by a square plus y square divided by b square is equal to 1. And a greater than b means the major axis is x axis. Here it is minus a 0, here a 0, this is 0 b, and this point is 0 minus b. The given solid is obtained by the revolution about the x-axis of the area enclosed by the portion of the ellipse in the first and second quadrant, that is this region. So this portion of the ellipse on the first and second quadrant of the ellipse is revolving about x-axis, then we obtain a volume of solid of revolution. And since the ellipse is symmetrical about the axis, so the required volume is twice that of the volume obtained by revolving the part of the ellipse in the first quadrant about the x-axis. Here the given curve, that is ellipse, is symmetric about x-axis. So to find the volume of the solid of revolution, you just take this part of the curve, and this is symmetric about x-axis, and 2 into pi integral 0 to a y square dx gives the total volume of solid of revolution. Since this is symmetric about x-axis, so I am taking only this portion in the first quadrant. 2 into that volume gives the total volume of solid of revolution. Here the limits varying from x is equal to, on the first quadrant, limits varying from x is equal to 0 to x is equal to a. This is revolving about x-axis. So from here to here x varies from 0 to a, and this part is revolving about x-axis into 2 gives the total volume. So the required volume is given by V is equal to 2 pi into integral 0 to a y square dx. And we have the equation of ellipse: x square divided by a square plus y square by b square is equal to 1, or y square is equal to 1 minus x square divided by a square into b square. So here y square dx means b square divided by a square into a square minus x square dx. This is equal to 2 pi into b square divided by a square into integral 0 to a square minus x square dx. Then we get the required volume: 2 pi into b square divided by a square into a square x minus x cube by 3, limits from 0 to a, into a integral a square dx is a square into x, minus integral x square dx is x cube by 3, integral x raised to n is x raised to n plus 1 divided by n plus 1 plus a constant c. Now 2 pi into b square divided by a square into, after applying limit a cube minus a cube by 3 and applying lower limit, this becomes 0. That is 2 by 3 pi b square by a square into 3a cube minus a cube, that is 3a cube minus a cube is 2a cube. 2 into 2 4, 4 by 3 pi b square into a cube divided by a square. So the final answer is 4 by 3 pi a b square. So the required volume of the solid formed by the revolution about the major axis of an ellipse with the axis 2a and 2b is 4 by 3 pi a b square. Thank you.